I welcome you all to the next session of electronic devices and circuits. One thing I would like to tell you, the number of viewers for the previous videos were very less. I think all the students are not able to listen to the videos. If you find it difficult to follow the videos, you can contact me. And nobody has responded with their exercise answers so far. At the end of every session, questions were given and nobody has submitted the answers of the exercise question. So I want all of you to watch the previous videos, okay, and submit the answers without any fail. You see, the subject electronic devices and circuits a very important subject as far as the electronics and communication engineers are concerned. So I want all of you to give due importance to the subject. Try to refer to any of the textbooks available in the net. Okay. So I will go on to today's session right now. So can anybody imagine what is shown in this diagram? So this is nothing but the first transistor developed at Bell Labs on December 16, 1947. So this was one among the most important inventions in the field of electronics and communication that has even changed the world. Okay, so whatever be the advancements in science and technology that we see today is attributed to the invention of this transistor. In this diagram, the diagram on the right hand side, this is the kind of transistors available nowadays. You know that in all these practical electronics devices, whatever be the device that we are using, whether it be a mobile phone, laptop, or a charger, whatever be, all these circuits are made using transistors in one form or another. Okay. You know that one of the most important application of a transistor is as an amplifier. So I'll discuss how an amplifier works or the amplifying action of a transistor. Okay. So this represents the common base transistor configuration. You know that emitter is the input terminal, collector the output, and base the common terminal. Okay, and as far as a common base transistor amplifier is concerned, it offers a very low input impedance and a high output impedance. Impedance is nothing but the resistance. Okay, it has a low output resistance and a high output resistance. In the diagram, we can see two voltage sources VEE and VCB. This VEE is connected to forward bias the base emitter region, and this VCB is reverse biasing this collector base junction, so that the transistor is operated in the active region. Okay, so here in this case we have the collector I, the emitter current IE, this is the collector current, and this the base current. Okay, so in this circuit we are applying an input signal, a sine wave we are applying. So of course this sine wave superimposed with the input signal VEE, the DC bias source VEE. Now at the collector resistance, a high value resistance RC is connected. This is acting as the load resistor, and across these two terminals the output signal is obtained. So across we are applying a sine wave input across here, and the signal is taken, the output signal is obtained from these 2 points. Okay, so the amplifying action of transistor can be explained only with the help of simple mathematical analysis. To the circuit, let us apply, we are applying an input voltage of say 0.1 volt. Okay, so we are applying an input voltage of 0.1 volt, and let the input resistance of the CB configuration is 100 ohm. Okay, so what will be this IE? IE will be equal to V divided by R. Of course, V in divided by R in. That is 0.1 volt divided by 100 ohm. So that comes around 1 milliampere. Okay, so IE will be equal to 1 milliampere. Now, for any transistor configuration, IE will be approximately equal to IC. So here, since IE is 1 milliampere, IC will also be equal to 1 milliampere. Now, since the load resistance RC is equal to 10 kilo ohm, the voltage across the resistance will be equal to IC times RC, which is equal to 10 volt. Okay, so while applying a voltage of 0.1 volt at the input, we are obtaining a 10 volt across the output terminals. Okay, so that is, the voltage gain of such a configuration can be calculated as the ratio of V out to V in. That is, V out is 10 volt and V in is 0.1. So we are obtaining the voltage gain of 100. Okay, or in other words, in this circuit, for example, we are applying a 1 volt as the input signal, we will be obtaining 100 volt at the output. Okay, that is, the input voltage is getting multiplied by a factor called the voltage gain. So if 1 volt is applied as the input voltage, this 1 volt signal is multiplied by 100, which is the voltage gain. So the output voltage will be 100 volt. Okay, so we can see here, the very low input voltage is getting converted into a high voltage. So what is amplifier? Or what is an amplifier, or what is the function of an amplifier? Of course, the amplifier just increase the signal strength applied to its input. If you are applying 1 volt, it is getting converted into 100. Okay, so basically an amplifier is just improving the signal amplitude. Okay, and there are different types of amplifiers as well: voltage amplifiers, then current amplifiers, power amplifiers, etc. So depending upon the application, we select the desired amplifier. Okay, so the selection of the amplifier depends on the application. Now, why we need an amplifier? That is again a question. So for example, from our day-to-day life itself, we all listen to radio or TV. Suppose we are receiving a radio signal that is transmitted from Trivandrum. Okay, so the signal, after traveling such a long distance, when the signal is received in our radio receiver, the signal amplitude will be very small, negligibly small. Okay, so before converting the signal into the perfect audio signal, the signal amplitude has to be raised. Okay, the signal amplitude has to be increased. Okay, so in such application we use an amplifier. Okay, then another application in a public addressing system. For example, if we are conducting a program in our auditorium, so whoever is presenting a program on the stage has to attend all the audience sitting inside the auditorium. Is it not? So in such case, the microphone output has to be amplified and is applied to a loudspeaker so that all the persons sitting inside that room can hear the sound. Okay, so wherever it is required to raise the signal strength, whether it be voltage, current or power, we make use of transistor amplifiers. Okay, so we'll continue in the next session.